And then it says once it gets there, it does a new bearing. So I'm going to draw a new north angle. Now this bearing is 72 degrees, so not quite 90 degrees. I wonder if I can. I didn't give myself enough space. I'm sorry if this gets confusing because it's going to overlap with the text. So at a bearing of 72 degrees, I'm peeling off. I'm not quite 90 degrees. So I'm going like this way to this next point. That means that this angle is 72. But I don't know what this inside angle is. I have to keep in mind that north versus south continues and cuts that angle. It doesn't cut it in half, but it does cut it in a way that you can find out. Remember all the way back to geometry, this is considered prior knowledge, so stretch back when talking about parallel lines and transversals that cut through them. Notice that this 9 degrees here and then this angle right here are alternate interior angles. Remember, it looks something like those two angles, right? Those are alternate interior angles. And remember that alternate interior angles are equal. So that guy, I'm so sorry, this is all squished. That guy is 9 degrees. This guy continues with 72, combines with 72 to make a straight line. And we remember that linear angles add up to 180. So in order to find out that angle that completes the line, I need to subtract 72 from 180, which is 108 degrees. Those two combine together to give us 117 degrees. Really messy. I'm going to take a second and redraw it below. I've got a triangle that looks something like this. I know that this side length is 280. I know that this angle in here is 117. And then I did have how far they went on that bearing. It was 1,320. So that means that this is 1,320. And that's all the information we have for that triangle, but it's starting to look familiar in terms of solving for non-right triangles. The 9 degrees helped us make the 117 degree angle. That's what it was there for. So it's not being used to find that angle down on the bottom left hand of the triangle because it's really relative to how far out that other city is. So it's really dependent on like all the other things going on here. So that 9 degree angle only helps us to make that 117 degree angle. So the first place that we were at was Calgary. So I'll put a C for Calgary. We started at Calgary and then we went to Edmonton. And then from Edmonton, we went to Churchill, Manitoba. So I'll do CH versus Calgary, which is CA. And we'll do ED for Edmonton just to stay consistent. How far is Churchill from Calgary? So we are solving for this distance. Hopefully things are clicking. You're seeing a pattern here. That pattern is that we're solving for the opposite side length. We have an angle with the two sides on either side of it. I'm going to think here that we're going to be doing law of cosines. C is the angle that I have, uppercase C, which is 117. Does it annoy anybody else that uppercase C and lowercase c are so dependent and yet they look so alike? It's been a constant bane of my existence. That's a little dramatic, but it definitely doesn't make sense. Those are all your pieces. And I've noticed that by putting together all of my pieces, I now have, I know that I only have one variable. C squared equals A squared plus B squared minus 2 times A times B times cosine of C. Plug it into your calculator. I get an E situation going on here. Please remember that that is scientific notation in disguise. Yeah, so I get x squared equals 2.16 E6, which is 2.16 times 10 to the 6th power, which is moving that decimal 6 times to the right. I'm not going to write it all out because I know I'm going to be taking the square root of it. So I'm just going to scroll up, take the square root of it. And I get that x is equal, does it say to how many figures? Nope. So we're going to do 3 sig figs. X equals, so it's 1468.47. 3 sig figs means that we stop here. In order to stop there, we have to look at the number after it, which tells us to round up. So it's going to be 1470. 1,470 kilometers. Very, very common with air flight, this application. And ships. Tons and tons of trigonometry with ships. All right, if an airplane flies at an average speed of 720 kilometers per hour, which means that every hour it goes 720 kilometers, how long is a direct flight from Calgary to Churchill to the nearest hour? Speeds are unit rates. They're fractions, right? This h to the negative 1 means it's divided by h. So think about that. 720 kilometers per hour is 720 kilometers per 1 hour. It's in how you say it, 720 kilometers per hour. Yeah. So if you went 2 hours, you went twice of 720, 1440, right? If you went 3 hours, you went 3 times 720. So it's a proportional relationship. So if I'm trying to solve for X amount of hours, given a certain distance, 1470, hey, I have my exact value in my calculator. I'm totally not going to be using this rounded value in order to solve. In order to solve, I do need to cross multiply. So I get 720x equals 1,470. Divide both sides by 720. I can just take what's already in my calculator from literally just doing it seconds before, divide it by 720, and I get 2.03, which means 2 hours. All right. Please let me know if you have any questions. These are our last notes before moving on to something that's not trigonometry, but still geometry. So this is the end of our trigonometry section. I really like trigonometry. I think it's really cool. It's definitely applied all over the place, especially in physics. So it's a common application problem to be seeing. We're going to be doing a cognitive practice the next class. So definitely try and have this and all of these notes in front of you as you're approaching the cognitive problems. All right. Thanks, guys.